Hello members of Tambuwal math class. Someone said I should solve x to the power of 5 minus 1 equal to 0. But I'm going to make it a marathon by solving x to the power of n minus 1 equal to 0. N from 1 down to 5. Don't forget to like, comment, and subscribe. Let's get started. If we should make it x to the power of n, remember, the degree of an equation will determine the number of solutions, except if you are looking for specific solutions. So we can take -1 to the other side. We have x to the power of n equal to 1. But remember, 1 is a complex number. So we can change this entirely from real world to complex world. Yes, we can do that. 1 is the same thing as 1 plus 0i, right? Because a complex number has imaginary and real parts. Something like this. A plus bi, right? This is how we represent a complex number. But in this situation, you can see only the real part is present. The imaginary part is absent, which implies that it is the same thing as saying plus 0i here, right? But it's not necessary because 0i is 0, plus 1 is 1. All right. Since this is a complex number, we can transform it into its polar form. The polar form of this complex number is r multiplied by cosine of theta plus I sine of what? Theta. Yes, this is the polar form. R is the modulus. Theta is the angle subtended by that complex number from the origin. So if you want to find the modulus r, is equal to the square root of what? A squared plus b squared, which implies what? 1 squared plus 0 squared inside square root, which is 1. Square root of 1 is 1. So you can see that r is equal to 1. If you are looking for the theta, it is equal to what? Tan inverse of b divided by a. b is 0, a is 1. And that will give you 0. But I want to visualize it for you to see everything. If you have a plane here, remember this is the real axis, right? If you're looking for a complex number 1, because this is 1, right? This is 1. It is 1 unit to the right, assuming this is 1. So you locate it here on the plane, on the real axis. So r here, which is the modulus, the distance from the origin to that complex number, you can see it is what? 1. Why we are taking the modulus? Because we want it to be positive all the time. So r is 1. What about the angle? No any angle has been subtended here because it is already on the standard position. If you want to calculate angles, you go either clockwise or clockwise or counterclockwise. All right. Therefore, the angle here is 0. And another thing you should know about these angles, they have their own coterminal angles. If you start from here, you go around additional of 360 or 2 pi, you have another coterminal angle, which means that you can keep on adding 2 pi, 2 pi, 2 pi, infinitely many times. So you can see that r from the plane is 1 and theta is equal to 0, but we can keep on adding 2 pi, 360. How many times? We don't know. So we can attach k here. All right. It means that this 1 is the same thing as r, which is 1. So we don't have to write it. Cosine of what? Theta, which is 0 plus 2 pi k is still 2 pi k. So let me use square bracket here. 2 pi k plus I sine of, what do you call it? 2 pi k. We are almost done. But remember, we are looking for x, not x to the power of n. Therefore, we can raise both sides to 1 divided by n, right? Because 1 divided by n times n will give you 1. So if you can take nth root of both sides. So x will be equal to cosine of 2 pi k plus I sine of what? 2 pi k raised to the power of 1 over n. Yes. According to De Moivre's theorem, this can multiply the arguments. So we're going to take this and multiply the arguments. So finally, x will be equal to just cosine of, if you multiply by 1 over n, it is going to give you 2 pi k divided by n. 2 pi k divided by n plus I sine of 2 pi k divided by n. This is the general solution for which k equal to 0, 1, 2, up to n minus 1. Yeah, if n is 5, you're going to stop at k equal to 4. You should know that. If n is 1, you're going to stop at k equal to 0. Already you have to start from 0 to 0, so you're only substituting 0 when n is equal to 1. When n is equal to 3, you start from 0 to 2. You get it? So let me rewrite it here. So now we have seen that the general solution for x to the power of n minus 1 is the same thing as k equal to cosine of 2 pi k divided by n plus I sine of 2 pi k divided by n, for which k begins from 0 to n minus 1. So let's start by solving the first one. Remember, I told you this is a marathon. What if you have x to the power of 1 minus 1 equal to 0? You know, x to the power of 1 is the same thing as x. Remember, we are starting from n equal to 1 down to n equal to 5. So this is as simple as taking negative 1 to the other side, which is going to transform it to positive 1, and hence x is equal to 1. This is the only solution here. Because degree is 1, we expect one solution. But we have to utilize that because this is our general formula to check whether this is true. I don't have to waste time. If you plug in n equal to 1, you can see this is 1, right? This is 1. So this will only be cosine of 2 pi k plus I sine of 2 pi k. But k always begins from 0. So this is going to be, everything here will be 0 because 2 pi times 0 is 0. Divided by 1 is still 0. We know that cosine of 0 is 1 plus whatever we get here. Sine of 0 is 0 times I is 0 plus 1 is 1. So this is true. Next, when n is equal to 2, you have x squared minus 1 equal to 0, right? You can take this one to the other side, which implies that x, okay, let me do it here. X squared is equal to what? Positive 1. The degree is 2. We expect 2 solutions. If you take square root of both sides, you have plus or minus square root of 1, and square root of 1 is 1. So the solution here is x equal to 1 and negative 1. But is this true? Let's test it here. N is 2, right? So the denominators will be 2, and 2 will cancel 2. What do we have to the top? Only pi k. But k begins with 0. So if you have 0 here, everything here will be 0, right? And cosine of 0 is 1. So we have one solution. Sine of 0 is 0. So everything here will be 1. Then as k is equal to, let me write it. Cosine of what? Remember, n is 2. It will cancel. We only have pi k, right? Plus I sine of pi k. We have seen that if k is 0, everything here will be 0. And cosine of 0 is 1. Sine of 0 is 0. So everything here will give us 1. But when k is 1, if you times, you're going to get what? Only pi. So cosine of pi plus I sine of pi is what we have to evaluate. What is cosine of pi? Is negative 1 indeed. Remember, it is on this axis, negative 1. And sine of pi is 0 times I is 0. So we only have negative 1. This formula is true. Then when n is 3, x to the power of 3 minus 1 equal to 0, it implies that x to the power of 3 is equal to 1. All right. One thing you should know that is 1 will always satisfy these equations no matter what n is, provided it is what? A positive integer. All right. When n is 3, this is what we are going to have. We're going to have cosine of what? 2 pi k divided by 3 because n is 3, plus I sine of what? 2 pi k divided by 3 as well. But remember, k starts from 0. So if you substitute 0 here, everything here will be 0, everything here will be 0, and this will be 1, this will be 0. If you add, you're going to get 1. So you see that x equal to 1 is a valid solution. So we have x1. Then x2, let me start it here. x1 is equal to 1. So what about x2? x2 is when you have k to be equal to 1. That is the next one. So this will be just what? 2 pi times 1, which is just 2 pi divided by 3. 2 pi divided by 3. All right. 2 pi divided by 3, that is in the second quadrant, right? Because in the first quadrant, we have pi over 3, and cosine of pi over 3 in the first quadrant is 1 over 2. In the second quadrant, where we have 2 pi over 3, it will be negative 1 over 2. All right, 1 over 2 in the first quadrant, negative 1 over 2 in the second quadrant, negative 1 over 2. You can use your calculator to confirm. Cosine of 2 pi over 3 will be negative 1 over 2. Plus, I is there, it is multiplying this. This is going to be positive root 3 divided by 2. Root 3 divided by 2, you attach I. This is a complex solution. And whenever you obtain a complex solution, its conjugate is also a solution. This is always true. So x2 can be minus 1 divided by 2 plus or minus root 3 divided by 2i, because I told you its conjugate will be a solution. So it can be minus 1 over 2 plus root 3 over 2i, or minus 1 over 2 minus root 3 over 2i. If you want to confirm, let's check when k is equal to 2, because that is the final one. If k is equal to 2, that 2 times this will give us 4, right? This will be, okay, let me do that elsewhere. I don't want to get confused. Cosine of 4 pi over 3 plus I sine of 4 pi over 3. All right. This is going to be in the third quadrant, so it will not change. It will be negative 1 over 2. Negative root 3 divided by 2, then times I. You see that? The only difference is that this is plus, this is minus. Therefore, we can have plus or minus. Yes. This is when n is equal to 3. Now, let us move on to when n is equal to 4. X to the power of 4 minus 1 equal to 0 implies x to the power of 4 equal to 1. 1 is always a solution, I told you. All right, in this situation, n is 4. So let me replace this with 4. This with 4. Remember, we have our k here. This is 4. This is 4. We have no problem with when k is 0, because we know this is definitely going to give us 1, because cosine of 0 is 1, sine of 0 is 0, 1 plus 0 is 1. So x, the first value, is always 1. Then second value of x, that is when k is 1, right? If k is 1, it will not change anything, but you can reduce it to the simplest form. 2 divided by 4 is 1 over 2. So this is going to give us cosine of pi over 2 plus I sine of pi over 2, which is 90 degrees, right? Cosine of 90 degrees is 0, definitely. Sine of 90 degrees is 1 times I is I. So it's like we are adding 0 and I together, which is I. All right, so this is I. But I told you that its conjugate will also be a solution. Yes, but let's confirm, let's continue. When k is, we are done with 1, then when k is 2, you have 2 times 2 is 4, divide by 4, it will cancel that, leaving only pi, right? Because 4 divided by 4 is 1, times pi is 5. So what happens if we have only pi here? That's when k is 2. This is cosine of pi is -1. This is 0. Okay, so you see we have 1 and -1. x3 is equal to -1. I told you that we are going to get -1 because whenever you have a complex solution, its conjugate will also be a solution, and that can be of 10 when k is 3. All right, when k is 3, we have 3 times 2 is 6. So we have 6 divided by 4, or we can simply write it as 3 pi over 2, right? Because 2 times 3, that is when k is 3, we still have 4 here, 2 here, 1, 2 here, 2. So you can see this is 3 over 2, but we still have pi. That is 3 pi over 2. So what happens if we have 3 pi over 2? 3 pi over 2. You should know that this is when k is equal to 3. That is 270 degrees. This is 0. Yeah, cosine of 270 degrees is 0, but sine of 270 degrees is -1 times I is -I. So you are subtracting I from 0. This is going to give you -I, which is the conjugate of this one. So x4 is -I. So you can say that x can be plus or minus 1, plus or minus I. Now, back to the main equation, which is x to the power of 5. So when we have x to the power of 5 minus 1 equal to 0, it implies that x to the power of 5 is equal to 1. Let's plug everything. This time around, I'm going to write everything because this is our main equation. We have x1 to be what? Cosine of, when k is 0, everything here will be, to the top will be 0 divided by n is 5, plus I sine of 0 divided by 5. You know, this is going to give you 1 plus 0, which is 1. x2 is equal to, when k is 1, 2 pi times 1 is 2 pi to the top. To the top, that is 2 pi divided by n is 5, plus I sine of 2 pi divided by 5. But this angle is not spatial. We cannot do that directly. Let's use calculator, but this is going to give us exact solution. So let me skip it. Let's go to x3. x3 will be, what's this? This should be cosine, sorry, we should have cosine here. Cosine of, is it 2 pi? 2 pi divided by 5 plus I sine of 2 pi divided by 5. Then x3, we have cosine of what? When k is 2, this is going to give us 4 pi to the top. So it is going to be what? Even. From 2 to 4 to 6. 4 pi divided by 5 plus I sine of, what do you call it? 4 pi divided by 5. 1, 2, 3. We still have 2. x4 will be cosine of, when it's 3, 3 times 2 is 6. I told you, even, right? 6 pi divided by 5 plus I sine of 6 pi divided by 5. Then the last one, x5 is equal to cosine of 8 pi divided by 5 plus I sine of 8 pi divided by 5. And these are the 5 solutions. 1, 2, 3, 4, and 5. The only real solution we have here is x equal to 1. So I have the solutions here. I think, let me just write them for you in decimals. This is approximately equal to cosine of 2 pi over 5 is 0.309 in 3 decimal places, plus this one is 0.951. Then don't forget you still have I. 0.951 is sine of 2 pi over 5, then times I. Then number 3, we have approximately equal to negative 0.809 plus 0.588I. This is number 3. Then number 4, we have approximately equal to negative 0.809 minus 0.588I. And the last one, we have approximately equal to 0.309 minus 0.951I. So if you observe, we have conjugate. Remember, I told you whenever you have a complex solution, its conjugate is always going to be a solution. Look at this one, where we have plus here. This one has minus. So this solution and this solution, they are what? Conjugate of each other. Look at this one and that one. This is minus, this is plus. Therefore, you can say that x equal to 1, x equal to minus 0.809 plus or minus 0.588I, meaning you have linked this one and this one together. Then you can do the same thing for this and this. All right, this is the solution to x to the power of 5 minus 1 equal to 0. In our next tutorial, I'm going to show you how you can solve this equation x minus 5, x to the power of 5 minus 1 equal to 0 algebraically.